Hi, this is a video on series and parallel resistors, and this is part 3 in the series. So let's look at this first circuit that I drew, and I want you to look at it, and I want you to try to figure out what the total resistance on this circuit is. So pause it, try to figure it out real quick. Okay, so I assumed you paused it. Now, the way you solve this is, well, let's trace this circuit. So if I am a current and I go this way, I'm going to go through here, then I'm going to get to this branch right here. And I can go down this way into these resistors, down that way into those resistors, or I can go this way through this straight line, which is actually a short, which bypasses both of these two branches of the circuit. So this circuit actually turns out to be really nice because you just go through R1 and then you go straight back to the power supply. So it goes all the way through here and back out that way. So really, this is really nice because the total resistance in this circuit is actually equal to the resistance in R1, which is just equal to 10 ohms. So when you guys have your test, look for little cheats like this. Sometimes your teachers will be really nice and put these on there just to see if you're paying attention. So pay attention. Now let's go on to the second one. Now in this one, I want you to also try to figure out what the total resistance is. I drew the circuit oddly, so it'd give you some problems. So pause it right now and try to solve for the total resistance. And then, okay, so I'll assume that you paused it and you try to work it out. So now I'll just solve it, and then you can just check your answer. So in this one, if you look at it, all these resistors are 2, 3, 5, and R4. They're all actually in parallel. If you'll notice, these are all connected right here. This would actually be the node, and they're all electrically the same point. And down here, it's connected here and at these two locations, but they're all connected on the same line, so they're all in parallel. So I'm going to redraw this circuit so it looks a little bit neater. Get rid of that. So yeah, let me redraw the circuit so it looks much neater. So I would recommend that if you get a problem like this on a test, that you just redraw the circuit. So let's draw, this is R1, and then you're going to have 2, 3, 4, and 5 all in parallel. So then I would just draw R2, R3, and this is R4, and the last one, R5. Now if you notice when I drew R4 here, I connected it right here, but it doesn't really matter where I connected it, so long as I connect it in here somewhere. And here you notice I wrote the line going all the way over here. Doesn't matter, it's still electrically the same point. So then it connects back down to here, and this is connected to the same spot there, and they're all just connected. So these are all in parallel, so that's how I drew them down here in a more familiar, I don't know, it just looks more familiar, I think. So I would redraw it this way. Let's scroll down a bit. And let's finish off the circuit. So I can connect it here, but I'm going to connect it here just because. So these are all on the same line, all of these. So these are all in parallel. And let's see, so this R1 was, what was it, 2 ohms, I think? No, R1 is 2 ohms, yeah, so let's put that down, 2 ohms. And R2, 3, 4, 5 are all equal to 8 ohms, which actually makes this problem really nice. So I'm going to show you 2 ways to solve for those. One's a little bit quicker than the other. So let's, first thing when we're going to do this circuit is you want to take all these right here and rewrite them. So as one resistor, so you could get them in, so you can work this problem. So you could solve for the total resistance, or the resistance in parallel, by saying 1 over R2 plus 1 over R3 plus 1 over R4 plus 1 over R5, which is going to get you 1 over 8 plus 1 over 8 plus 1 over 8 plus 1 over 8 again, for a total of 4 over 8. It's going to be equal to 1 over the resistance in parallel. So if you just flip these two values, you're going to get Rp is equal to 8 over 4, which is equal to a total of 2 ohms. Now you could have done all that, and it'll take a little while, or you could do, you could do this, and this is more of a special formula, and you can do this formula whenever you have the same resistances in parallel. So if you have these resistors, 2, 3, 4, 5, any resistors, and they're all in parallel, and most importantly, they're all the same. They all have the same resistance. You can use this formula, and this formula will save you some time. So you say the total, or the resistance in parallel, is equal to the value of the resistor, or the common resistor, divided by the number of resistors in parallel. So here my resistance is 8 ohms, and there's 1, 2, 3, 4 of them. So I'm going to say the resistance in parallel is equal to the value of the resistor, which is 8 ohms, divided by the number of resistors, which there is 4, which gives me a total of 2 ohms. So I think this one I'll give it to you a little bit quicker than the other way, much less writing, much neater, I think. So I would go with this route for this type of problem. So now let's redraw that circuit. Here's what it looked like initially, and here's what it looked like after we redrew it. And now we're going to redraw it one more time. And that's 2 ohms. So now you're going to have the power supply. This is R1, which is equal to 2 ohms. Now you have Rp, and that's also equal to 2 ohms. So now to get the total resistance, you're just going to add R1 plus Rp, which is going to be 2 plus 2, which is equal to 4 ohms. Yeah, and that's how you solve for this problem. So I hope you got that answer. I hope you liked the video. And good luck in your classes.